Right. So we're going to look at once again the derivatives of inverse hyperbolic functions. Okay, and what we look at in this video is the derivative of the hyperbolic tangent, the inverse of that. So if we have, let's say we have y is equals to hyperbolic tan inverse of x. I want to find what the dy dx is. So in order to say, we can express this as what? As a hyperbolic tan of y. Okay, and what we do here is that we need to differentiate both sides. Okay, we need to differentiate both sides of what we have. So remember to say, when you differentiate with respect to y, you are going to get your dx dy uh, being equals to hyperbolic secant squared of y. Okay, so meaning our expression for dy dx will be equals to 1 over hyperbolic secant squared of y. And from the identities, we understood that we understood that uh, hyperbolic secant squared of x, but in this case I'll use y, plus c, hyperbolic tan squared of y is equals to 1. So if we are to make a secant, um, hyperbolic secant squared of y the subject of the formula, we're just going to get hyperbolic secant squared of y being equals to 1 minus c, um, 1 minus c hyperbolic tangent squared of y. Okay, so here what you're going to get is, before maybe I even write the final expression, we know what our tan is. Okay, so we know to say our x is equals to hyperbolic tan of y. So instead of us using this here, we're going to replace with what? With x squared there, because we have a hyperbolic tan squared of y, not just hyperbolic tan of y. So meaning our dy dx is equals to our 1 over 1 minus c x squared there. So of which this is simply a u prime divided by 1 minus c u squared, which is our dy dx, that like that. So that's how you come up with that. Thank you very much for watching.